Welcome to the Gridwise Architecture Council's video library. The following presentation by Ron Ambrosio is entitled Back from the Future, Reaching the Vision of Tomorrow's Grid, and was presented to the Gridwise Architecture Council on March 19th, 2025. Welcome, Ron.
I'm going to cover this pretty quickly because Jamie gave me 40 minutes and it's an hour-long presentation. But for most of this audience, some of the things in here are well known. For others, it may be the first time you're really seeing it, but I'm going to kind of go through a little quickly on some parts of this so that I think we'll be able to do this in 40 minutes without too much trouble. All right, so just as background for those who haven't been on some previous calls, this is a new presentation that we put together. Rahul Bahadur and I and some others pulled it together from material that we presented at conferences the last 2 years, and we're going to use it in order to schedule some webinars to share this concept and the importance of grid architecture with the broader community. So that's why you see the presenters and fill in the date kind of information. This is now the final version of this deck, and so we're going to look at starting to schedule a couple of webinars to present the material. But wanted to run through it for the whole council and for the guests. Again, a little bit quickly, but everybody will see what the whole deck looks like. If I can get it to page forward. There we go. So introduction, future of the electrical grid. How do we get there and where is there? And we've been using the analogy of bridge building quite a bit in this discussion. So you have to, by the way, I'm going to give people a heads up. Our landscapers are here today. My Yorkie has not agreed to having them visit, so you may hear a dog barking in the background from time to time. Okay, so what will the future hold for power grids? What's achievable, believable, acceptable? What are the market conditions needed to get across that bridge from where we are today to where we're going? There she goes. What step changes are needed to get there? Who are the targeted? I'm going to pause for a second. They're running a gas-powered leaf blower right outside my window for a moment.
Ron, we don't hear it.
You can't hear anything, so you're good, Ron.
You're the only one being annoyed.
Yeah, I know, but I can't hear myself or anybody else. Give me about 10 more seconds. Okay, that's good. Yeah, the headset that I wear, it cancels out all of that noise. You guys don't hear it, but I can't even hear myself talking when they're doing that. Okay, so what are the step changes that we'll need to get from here to there? Who are the targeted stakeholders of this change? And what's beyond the 25-year horizon, the 50-year, the 100-year? The guiding principles that the council is trying to focus on currently are decarbonization, addressing the crisis of climate change by removing fossil fuels, creating policies and implementing strategies to incentivize the growth of carbon-free sources in a sustainable manner. Decentralization, develop operational market and planning strategies and policies to maximize power system and societal benefits of distributed energy resource technologies and end-use customer participation in system operation and energy markets. And democratization, ensuring that policies for decarbonization and decentralization embody energy justice principles, with an emphasis on the ability for local authorities, communities, and customers to participate in the planning, deployment, ownership, and economic operation of electricity assets, to achieve an equitable distribution of energy, economic health, and other benefits across all of the segments of society and the planet in general. So those are the three big themes, the 3Ds. So why is all of this important? Why is it needed? Well, the grid is aging and requires investment. The energy landscape has changed, and the current grid needs to reflect our decarbonization, decentralization, and democratization goals. Why is this a good thing? Well, a good plan for the grid is also good economic policy. We'll avoid stranded assets as much as possible. We'll avoid wasted investment. A shared vision benefits customers, decision makers, and stakeholders. And what happens if we don't do this? We'll be constrained in the ability to accommodate buildings and transportation modernization. We'll see increased instability of the grid and daily societal functions, and there may be a substantial increase in cost of achieving future needs. And when we talk about substantial worldwide, we're talking in the trillions of dollars, not even the billions. Here is one example stake in the ground about what things may look like in 25 years. This is not a statement of what the council has agreed on, but it's one example of the kinds of things. At least 50% of this might be believable, achievable, and acceptable. That's how we're defining a stake in the ground here. So 90% reduction of fossil fuel as a primary source. Grid architecture shifts to primarily distributed system focus. Grid upgrades focus on DERs and bulk generation as equals. Transactive energy becomes common across all customer segments. Safe fusion-based energy sources may be demonstrated within 25 years. No coal-based energy sources in the U.S. grid. Well, clearly that's a stretch goal. Natural gas source reduced by 50% from the 2020 level. Grid load increases by 80% or more as we see more electrification of transportation, for example, and other sources, and continued electrification of buildings, cities, and transportation. One of the things that the council has done over the past couple of years in order to help understand that future vision, and the council does not define that. We're trying to reflect what the industry community is looking at as future vision, future states. Okay, so this project that I'm describing here was an analysis of vision and future states from 10 organizations listed on the right side there. The objectives were to identify stakeholder vision future states, what are the similarities, what are the differences, the divergence, and the stakeholder impacts across the statements from these 10 organizations, and what are the architectural challenges that emerge. Okay, what grid architecture, structural and technical challenges do we need to address? What we found is similarities, probably pretty straightforward and believable. The electric grid is going to change significantly, and we need it to be efficient, affordable, and economic. Okay, that's, motherhood and apple pie. Differences are in the stakeholder involvement. We really had a mix of some of these organizations calling out all parties and stakeholders, and others were just focused on the consumer, customer, prosumer. And also clean energy and environmental protection. Only about half of these organizations called that out as a key future requirement. As far as identified architectural challenges, developing new industry structures, transitioning to a distributed model of the grid, transitioning from silos to platforms within energy organizations, utilities, and others, developing more effective data exchange, enhancing control and coordination in distributed structures, standardizing interfaces and structures, and structures that are able to accommodate large amounts of distributed energy resources. So we've got several organizations' view of the future. We've got some analysis of those. So, we've got something to work with as to where we want to be in the future. The question is, how do we bridge the gap from today's grid to that future vision, which we're referring to as back from the future? One important claim that we're making is that incremental forward planning alone is not going to get us there. So this infographic is showing, and it's from work done in Australia, but it was really originally based on work from the Pacific Energy Institute, showing sort of 3 phases of increasing variable renewable energy and distributed PV and DER in general from a today, let's call 5 years, maybe it's 5 years, maybe it's 3 years, maybe it's longer. We probably should remove the the timeline quantification there. And then finally to a very high penetration in the future. The key point of this is that as we incrementally move forward from today's grid implementation and design, we're going to start to run into constraints that are inherent in the current power system architecture. So it's going to be important at some point to begin to design and implement and plan for whatever step change is needed from the current architecture and where it can get to a new starting point in the middle there that brings us into that future state of high DER penetration. One of the goals is to try to minimize that gap between the blue trajectory of today's system and the red trajectory of the future system. Minimizing that gap is minimizing the economic cost of this step change. And that's the gap that I was referring to earlier when I said the cost of not planning for this correctly could lead to trillions in infrastructure adjustment rather than minimizing that. So grid architecture tools are an important tool for enabling design from both a present forward and a future back perspective, from deterministic centralized fossil fuel based systems that we have today to a highly flexible, hybridized, and net zero grid in the future. So from the right to the left, present forward, from the left to the right, future back. And we want that Sydney Harbor Bridge to meet in the middle and not be off by a couple of feet one way or the other, which of course would be very expensive to fix. If you put it another way, where are we now? The as-built system. Where are we going? The target system. And how do we get there? How do we sort of say that green star is our end goal? What are the steps, if we were to move backward, that we would have had to go through to get from the blue star to the green star? Of course, as we're decarbonizing power systems, they become increasingly volatile. Variable renewable energy becomes a larger proportion of the supply, both at the bulk level as well as at the customer end and in between. But we still need to keep the grid in balance every microsecond of the year as we start to remove more and more of that bulk fossil generation fleet. So that's one of our key challenges. So the power system that we believe is going to be emerging is one that requires an entirely new level of dynamic whole system interdependence. There's lots of talk often about the graying of the delineation between transmission and distribution. Well, this is reflecting the fact that that line is blurring, that we're going to have a lot more cross dependency back and forth, and the load served by bulk might vary at an extreme from 0 to 100%, while locally supplied, again, also may become 0 to up to 100%. So there's a constant shift back and forth of that balance. So grid architecture is a tool for getting there. And it's about structures. So the grid can be viewed as a network of highly interconnected structures. On the right side, that diagram represents those structures. This is work that came out of P&L. You've got, for example, digital superstructure. You've got control structure, protection, control, synchronization. Electric infrastructure, that's the actual physical topology, the load composition, generation structure. You've got industry structure as we get into more of the business and operational descriptions, regulatory structure. In the middle, the grid structures are the coordination framework for all of this. And then convergent networks in the lower right, that's really where we start to talk about the interconnection of the grid with other infrastructures like fuel, like transportation, like other social entities and infrastructures. So planning for DER integration has to account for all of these multiple grid structures simultaneously. And so it should incorporate knowledge of grid architecture concepts. Grid architecture is about structure, and structure sets the limits on what complex systems like the grid cannot do and can do. So a high-level description of grid architecture. An architecture is an abstract depiction of a system. It consists of black box components, structure, market viability, and externally visible characteristics. Grid architecture is the highest level representation of the electric grid with ultra large scale complexity, and it enables reasoning about the grid's properties, behavior, performance, economics. So what we have here on the right is market structure influences all three of these levels of grid architecture. There's system architecture, there's theory of networks, large-scale networks, and there's control engineering. All of those have to blend together, and that's what leads to grid architecture. The reference at the bottom has some very good reference material on this work that was done at P&L. So, critical issues that grid architecture can help us identify. So these are architectural issues that negatively impact the operability, the resilience, and the cost efficiency of decarbonizing a grid. In the backup material for this presentation is the more detailed version of this page, which has a paragraph description of each of these 7 items. But very quickly, since I want to make sure we finish up on time, issues of tier or layer bypassing. If you think about the grid from a top-down, approach of bulk generation to transmission down to distribution, down to customer domain, you don't want to have, for example, something at the transmission level, say an ISO that's overseeing things, directly communicating with customer demand response assets and influencing them without the distribution layer in the middle being aware of that, because that distribution layer is going to be affected by things like that. So that's what one example of tier or layer bypassing. Coordination gapping. Are we making sure everybody is coordinating with everybody else that they need to? Are there any hidden couplings within the operation of this ultra complex system? Again, using the ISO managing DER example, there may be some hidden couplings there that are causing that. Latency cascading. If we have too many layers involved in every decision, then we're going to have to add up all the latencies as we step through each of these layers. Again, that ISO might need to deal with the fact that there's significant latency going through all the layers down to DER resources. Are there any information technology computational time walls? We're trying to manage and model an extremely large, complex system. Can we do the level of computation, the level of modeling and simulation in real time that we need to? Are there cybersecurity structural vulnerabilities? Obviously, the more interfaces we add, the more different systems we add, we're increasing the surface space of that vulnerability. And then back-end integration constraints is the last one. So, and I'll go through this part a little quickly because this is older GWAC material, but one of the points that we want to make is that the GWAC stack is still relevant today to grid architecture. And this is the GWAC interoperability context setting framework, which has been used widely in the industry, and we make use of it even today. It's still an extremely helpful artifact. It also includes cross-cutting identification. The relevance to grid architecture is that it still provides a framework for identifying system qualities and properties of the grid at all levels, not just technical, but also informational and organizational. So the business layers and the policy and regulatory layers. It defines key points of interaction, interoperability, and integration. It allows experts to work within their domain, but understand the impact across the whole stack. And together with NIST's smart grid model, these two artifacts provide a consistent approach to design validation, including grid architecture design validation. So, in conclusion, the takeaways are the vision of where we're going includes the 3 Ds. There are North Star. Bridging back from the future visions provides clarity on potential step changes that may occur or have to occur in this transformation. Grid architecture is a tool to help us get there, decomposes a complex problem into approachable activities. And the GWAC stack is still relevant, unbiased and cooperative expertise on how to get there. Call for action is education and training, documentation and resources, continuing standards and specifications development, policy-based briefings, and a primer that we probably want to develop as we've done with other work in the past. And these are in progress in the council for non-technical communities such as the policy and regulatory communities and the business community, code and compliance, and model simulations projects are all key to developing the future grid, both design and implementation.
Thanks, Ron, for that quite interesting presentation. For more information about the GridWise Architecture Council, please see our website at gridwiseac.org. And don't forget to subscribe to our YouTube channel at the site listed. Thank you.